Hello, everyone. Good afternoon. Okay, welcome, everyone. I've finished grading all of your exams. Everything should be graded now. I'm not sure if I have any homeworks left to grade. Let me just look really quick. Let's see here to review. Oh, let's see. Yeah, I have one homework left some homeworks left to grade, but pretty much your current grade should be reflected on the test. Or sorry, on your Google Classroom right now, so you have an idea of what you have. Um, on the test, there was one thing that I did notice, unfortunately, I noticed a few students had like very similar answers, and I understand, it's very easy to pass along answers in this class, but hopefully, you still learn the material, and remember, you could always do a retake if needed, at least for future exams moving forward. So there's no reason really to copy off of each other. I just noticed some kind of idiosyncrasies, I guess, that like some questions people wrote the same sort of strange thing. Yeah, please don't do that, because it's really important to try to make sure you're learning the concepts, and if you make a mistake, if you miss something on test, I definitely try to be pretty understanding, especially in this kind of learning environment. Um, if you felt like you didn't understand some concepts on this last test, don't hesitate to reach out to me. Um, I'm possibly considering doing a slightly different format for the final, but probably will be the same thing. But I will think about it for a little bit. Yes, let me see. Question. There's only going to be retakes, and for this last one, I don't think there will be. Only retakes, and you have to submit full corrections. The final will be. I'll post it in the classroom. When will the final be? So the final will be on. Let's say the final will be on the 21st. So Thursday, January 21st. I'll post it here. So Thursday. Okay. So let's continue. And yeah, if there were any concepts, I think overall I was really proud of a lot of you guys. Many of you did excellent. And and those of you who missed some questions, also, I know it's um, uh, not the easiest topic, but I think mostly everyone did really well. Um, and I hope that you feel more comfortable with roots and exponents, and that these concepts that a lot of people find really confusing, I hope you see that they're actually not as confusing as they seem once you understand what they're actually talking about and what they mean. And they're even kind of fun. I kind of like roots and exponents because once you know the mechanics and you understand what they're talking about, it's actually really straightforward. Okay, let's continue with completing the square. So recall last time we want to figure out a way to go from standard form, so like something in standard form, a parabola in standard form, like y equals x squared plus 10x plus 2, and we want to figure out how do we write it as a vertex form. Can we just rewrite it? And this is still going to be the same equation, same parabola, but just going to look a little bit different. So we have y equals a x minus h squared plus k. And we got to find these numbers, these constants. So there's a strategy to do this called completing the square. And before we try to jump to that strategy, first we say, well, what does it mean for an algebraic expression to be a perfect square? Well, those are types of expressions that, just like a square number, like you guys know the perfect square numbers. One squared is 1, 2 squared is 4, so 1, 4, 9, 16, 25, 36, 49, and so forth, right? Those are the perfect square numbers. In algebra, perfect squares are things that just come from a square of a simple expression. Then it's a perfect square. So perfect squares in algebra are simple expressions just squared. So like we would say this is a perfect square, x plus 5 squared, x plus 2 squared, x plus 3 squared, x minus 2 squared, x minus 1 squared. Let's do x minus 7 squared. Okay, please really quickly do all of these 6 questions on your notes. And message me when you're done. Hey Archer, glad you're finally here. So this is just a quick exercise. Message me if you're stuck on any of these, but this is a good review of just basic foiling, but it's foiling of perfect squares, and we'll see that there's a really nice pattern. And I think many of you know this pattern, but it's really important that everyone kind of reviews and sees this pattern again. And the goal of today is we're going to learn how to do this strategy of going from standard form to vertex form. And at the end, we'll see why that's useful beyond graphing a little bit. And then hopefully by the end of today, you'll see how to prove the, or kind of get you on the path to proving the quadratic formula. Okay, let me know when you're done. And I'll just message some students, see how you guys are doing. Oh, whoops, my bad. I didn't have this one I want on square. So all these perfect squares, always the same expression times itself. Oh, 1 second. Okay, nice. I got some good answers here. Very good. Awesome. Okay, so I'm just going to go through these here. Stop me if there's any questions that you have. The first one is x squared plus 10x plus 25, right? Just kind of, maybe I'll do it a little bit, just kind of do the foiling out, just this one. Get that g back in here. So x plus 5, x plus 5. You get the x squared, you have the 5, then you have 5x, and you have another 5x. So that's what gets you to 10x. And so doing the same pattern for the other ones, you guys find x squared plus 4x plus 4, x squared plus 6x plus 9. But with a minus sign, it's going to be the middle term. It has a minus in it because it's negative 2x plus negative 2x. So it's two of them. The last term is still positive. So we have this x squared minus 2x plus 1. And this is x squared minus 14x plus 49. Okay. Are there any questions on any of these examples? It looks like many of you got them, but I'm happy to go over any detail, any question. Please hit yes if this is a little review and you feel really comfortable with this question. Awesome, cool. Got a bunch of yeses. Nice, thank you guys. All right, so what we're gonna do today is with completing the square, we essentially do the reverse. We see an expression in standard form and we try to guess which perfect square it could have come from. And if you notice, the pattern is really easy. So just ignore this last term and just focus on the x squared and the term with an x. Can anyone tell me what's the only perfect square, simple perfect square, that x squared plus 10x could have come from? Nice, Gabby. What do you think?
Oh, I said x plus 5.
Nice, exactly. Because do we have that one? Oh yeah, we have it. That's the first one actually. So that one comes from x plus 5. And if you notice, in the vertex form, the way we have it written is a number times a perfect square plus a constant. So if we know x squared plus 10x, the only perfect square it could come from is x plus 5. That's a big hint on how we can do it. So we're going to do something really sneaky here. And this is the way I like to do it. There's different ways of setting this up. But this way, yeah, I'm going to show you. Let me think. Yeah, I'll show you this way. So there's two ways of doing it. They're the same thing. So the first way, which I think is nice, is, well, ignore the plus 2 and just think about this. Gabby said that this comes from x plus 5. This looks a lot like x plus 5, but we're missing something. So I'm going to write over here. So can anyone tell me, what are we missing? What number do we wish we had right here so that we can kind of unfactor it, or sorry, we can factor it to write it as a perfect square, as an expression square. What number do we wish we had? So what is missing at the end of this to make it a perfect square? Because it came from, Gabby said it correctly, it came from x plus 5. But what does x plus 5 squared have that this thing's missing? There's some number that x plus 5 squared has, but this thing doesn't. Does anyone see what it is? This is x plus 5 squared. What does it have that this doesn't have? Nice. Nice, Hannah. Yes. Hannah, what do you say?
I thought it was 25.
Exactly. Yeah. I just wish we had 25 here, because then we can write it in perfect square. Well, can we just add 25 randomly? Are we allowed to do that to an equation? If I want to add 25 here, what do I have to do to make sure that the equation still is the same equation?
Add it to the other side.
Exactly. So there's two approaches. You can add the number that you want to both sides. Let me make it a different color. So we do plus 25. And then over here, I do plus 25. And this is what we mean by completing the square. So now we've turned this expression, which was not a perfect square, because it was just x squared plus 10x, now we've turned it into something by really understanding the pattern here. We can predict the number that's missing. We can calculate it, because you just have to divide this by 2 and then square it. That's the number that you wish you had. So we can add it to both sides. And now we've completed our square. And then the rest we can just reorganize. So this becomes, by our, the reason we're doing this is so that we can next write x plus 5 squared. There's a plus 2, but now I want to get, I'm going to do it in 2 steps here. I want to get y by itself. So then I just subtract y from both sides. So this becomes y equals x plus 5 squared minus 20. And what's the vertex? Just a quick review. Oh, the +2, very good question. The +2 came from, let me kind of rewrite it here, from this original equation. This was just a random equation that I thought of, and I just rewrote it here, but I moved the +2 over to the side. That's all. Okay, now that we've written it this way in vertex form, can anyone tell me what the vertex is, and is this pointing up or down? It's pointing up. Very good, Allison. Nice, man. Yes, excellent. Oh, close, very close. So this is a parabola. That's, let me just kind of sketch it. It's pointing up, and it's located at -5, -23. -5, -23 is the vertex. And it's not skinny or narrow, it's just normal old parabola. So there we go. So now that we've done that, we can sketch it like that. There's another trick you can do if you don't like adding and then subtracting. Sometimes what people do instead is they do +25 -25 on one side. So that's another thing you can do. You can right away do +25 -25, and that's just 0. So you can do it like this. An alternative way of doing it is y equals x² plus 10x. And then you say, oh, I wish I had 25. So let me do +25 -25 plus 2. And then you regroup, and then this becomes x plus 5 squared minus 22. This is the same thing. Either way is fine. Be careful. You do have to be careful with this way. Sometimes we'll see when the parentheses are involved. When there's a number in front of the x squared, you sometimes have to be careful. Okay. Are there any questions? Because I might have been a little bit confusing there. Let me know if there's any questions. Hit yes if that made sense and you're ready for the next step. You want to do a little bit of practice. Nice. Okay, excellent. So let's just do a little bit of practice now. I'm going to give you guys some equations in standard form and just ask you to complete the square to rewrite it in vertex form. And then message me when you're done. As you finish each of them, let me know when you're done. So let's do some examples. And with these, it's just about practice. Like the idea, the pattern is not that hard, but it's easy to get a little bit mixed up if you're not careful and thinking through doing the algebra carefully. So let's do y equals x squared plus 8x minus 4 and y equals x squared plus 12x, I'm going to do this one, minus 12x plus 5. And let's do y equals x squared plus 5x plus 1. And then y equals x squared plus 6x. Okay, so these are 4 questions to do. Hopefully you can do them all fairly quickly. So write them, write in vertex form. Write in vertex form. And then identify the vertex. So these are kind of intro questions to this. Next, we're gonna, after we do these, we're gonna learn how to do it when there's a number in the front here. Um, and that will, it will be similar, very similar to this. And maybe I could get some volunteers to just write their answers on the underneath each one. So maybe when you're done, or if anybody wants to volunteer for these, that would be really awesome. You guys can annotate and just maybe pick a color or something and write underneath. And let me know if you need some help also. People are allowed to annotate. Yeah, message me if you're stuck. Please make sure that you're doing these because it's you know, a good time to practice. And I'm happy to check your answers when you're done. And you can send me a kind of as you finish each one. The only one that's really a little bit tricky is C. Nice. So I'm talking with a few students who asked me really good questions. If you have any questions, this is a great place to ask. Also, you can also ask in voice if you have something. Um, Gabby and Olivia, when you guys write up your answers, can you just write like maybe like 1 or 2 steps, not just the final answer, maybe just steps, and then if you want, you could explain it also. But I'm happy to explain it. Thanks, guys. And anybody for C and D? C and D are a little bit trickier. I mean, same steps. And I got a few people that were a little bit confused as well, so I want to try to message them. And I want to. Oh, okay, yes, you can write the full answer as well. Just like your algebra steps, just kind of show your a little bit of your work if you can. Maybe I'll give you guys a little bit more space. Struggling here. Could be here. See there. Oh yeah, you guys can write on the screen. Go ahead. Any volunteers for C and D? Oh, can you? Oh, nice. Okay, good, excellent. I see you guys ready. Yes, and anyone who has anywhere if you're confused with how to proceed at all, message me. This is a great time to message me. And no volunteers yet for C and D. Anyone want any takers on those? Nice, good catch. Who was that, Olivia? Yes. Okay. Let's see. I'm going to reply to some more students here. Awesome. Can you do deep, please? Oh, Allison? So with these problems, it's neat because you're not really solving anything. You're just kind of manipulating it with a strategy in mind. Uh, um, and uh, Gabby, for part A, on the very first line, can you just also write y plus 16? I think you're missing the plus 16 in the very first line as well.
Okay.
Thank you. Okay, awesome. All right, we got all the answers here. Thank you guys for volunteering. Wonderful. Okay, so I'm going to just kind of walk you through. I know there were some questions and some confusion a little bit about the steps here. Um, so let's just kind of go through the first one together. So, and I'm going to try to highlight. So, you know, we first see x squared plus 8x. And the thinking is, well, I know the perfect square that this comes from. To always figure out the perfect square, it's really easy, right? We saw the pattern. The perfect square always doubles this number, or is you know, whatever it is, x plus whatever squared, it's always that that missing number will be doubled. So to go to the perfect square, you just take this number and you divide it by 2. So we know that it has to come from x plus 4. We know that for a fact. But what it's missing, x plus 4 squared, you know, x plus 4 squared, this has a 16. So there's one step that I like to write here when I'm kind of showing this to other students, is I like to say, you know, rewrite the whole equation, but write y plus 16, just kind of how Gabby had it here, but then also write a plus 16, one more line like that, plus 16. And then I say, oh, I know by design that that's x plus 4 squared. And then the rest of it is just moving the 16 over to the other side, and then you're done. Are there any questions on what the idea is there? Um, and here for B, Olivia did a great job. You have x squared minus 12x. You know that that comes from x minus 6 squared, but we don't have x minus 6 squared. We have x squared minus 12x. We're missing the number. And what's the number that's missing? It's plus 36. So you can write plus 36 on both sides. So that's the plus 36. And Olivia here already kind of include the plus 36, and by design it's going to come out to x minus 6 squared. But if you wanted to, you could write, you can write an extra line, x squared minus 12x plus 36. You don't need to, but this could help you kind of visualize. And then there's also plus 5, right? So we just rewrite that as an extra line, and then that is x minus 6 squared. Okay. Are there any questions at all? Please stop me here if you have any confusion. I don't want anyone to be lost or fall behind. And I know, if you haven't seen this before, it's a bit of quite a bit of manipulations, and there's like a little bit of a strategy. So, are there any questions? Hit yes if you were. Please hit yes if you were confused a little bit earlier, but now you feel like you have a better grasp of what the steps are. Cool. Hit no if you're still a little bit confused. I'm happy to go over any of the examples. Okay. Oh, whoops. Let me keep it as it is. Gabby, could you explain what you did for C? Because that was a little bit different, and you did a great job.
Oh wait, sorry, I didn't hear you said.
Oh, no problem. I just asked, could you explain what you did for C?
Oh yeah. So
and how is that a little bit different, and is it really a big deal?
What I did, because like 5 isn't like a square in a way, like for like this, I just chopped it in half into what like it was perfect, but it was a decimal, so 2.5.
Uh-huh.
So it'd be x plus, sorry, I like wrote on here, but it looks really bad. It's x plus 6.25 equals x plus 2.5 plus 1, because I did the full FOIL of the x plus 2.5 and x plus 2.5 to get the 6.25.
Excellent. So just one comment, and just notice this now. Maybe could you write over here, just fix it up with the y plus 6.25.
Yeah, let me do it right now. It's going to be like on top, but it's like right there.
Yeah, we can even write, yeah, that's perfect.
Okay, there we go. And then
let me see here. I see. So, very good. Go on.
Okay. And then I like subtracted this minus 6.25 from both sides, and I got y equals x plus 2.5 squared minus 5.25, which ends up being negative 2.5 comma negative 5.25 in the parentheses.
Perfect. Excellent. So the key is that whenever you're completing the square and the middle number, the middle coefficient is even, it's really easy. Just divide it by 2 and you square it. That's the number that you would need to add in to both sides to complete the square. But when it's odd, as Gabby noticed here, you're going to get a fraction. So when you divide it by 2, you're not going to get it, because this is odd. When you divide by 2, you get 2.5. And so if you want instead, you can also, instead of doing like 6.25, like 2.5 times 2.5, which is not terrible, you can also just work with a fraction. So you can also have done it as, instead of 6.25, you could have just done 5 halves times 5 halves, which is going to be 25 over 4, which is the same thing. But you're also welcome to just use fractions if you want. Any questions on that one with the odd number in the middle? Do you see how it's literally the same steps, but we just have to deal with a fraction? Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, 106, 107, 108, 109, 110, 111, 112, 113, 114, 115, 116, 117, 118, 119, 120, Okay, and then Olivia, could you explain what you did for D? You did a great job.
Okay, so for D, I divided 6 in half and got 3. So then I multiplied that together and got 9, and then added that to the y. And then on the other side, I put x plus 3 squared. And then from there, you have to get y alone. So I subtracted 9 from both sides, and then that leaves y alone. So then the equation just kind of writes itself.
That's it. Perfect. And then you have the vertex -3, -9. Nice. Okay. Are there any questions? So just because there's a number missing, this is sometimes where students get confused. Say, oh, there's a number missing. Maybe this is already a perfect square. This by itself is not a perfect square. Remember, perfect square is just has to look like something expression squared. This is by itself not a perfect square. So you add 9 to both sides, and then you move over the 9, and then you can do it. And yeah, I like to always include slightly one more step for each of these problems. I would always actually literally add the 9 and then write it as x plus 3. You know, write this whole thing. But I actually like to have one extra line where I have x squared plus 6x plus 9. This way I can see that it's actually x plus 3 squared. But you don't need to do it. Okay. So far, so good? So now, whoops, let me clear these. Okay. So now, what do we do if we're faced with a number in front? So y equals 2x squared plus 20x plus 10. Do I just want to take the 20x and divide it by 2 and figure out what the perfect square is? Anyone? What do you guys think? Is it the same pattern? Nice. Gabby, what do you suggest to do here?
I said to divide the whole equation by 2.
Nice. And why the 2? Why did you put the 2?
Because everything on there is a factor of 2, like every number, and you want to get x squared by itself.
Exactly. That's right. So we want to make whenever we do this method works really great as long as the leading coefficient of x squared is just 1. And that's just like a little detail you have to remember. This is called a monic. So whenever the leading term, the highest power in the polynomial has a 1, we call it a monic. So this method is great for monic quadratics, or polynomials that have quadratics that just lead with 1. So exactly, we divide everything by 2. We can turn it into a problem that we can solve. So y over 2 equals x squared plus 10x plus 5. Okay, what is missing from this perfect square, or from this quadratic and like x squared plus 10x? What do I need to add to it to make it a perfect square? Nice, 25. Again, it's the same one. So I'm actually going to go in slow. I like to write it out. So I want to do plus 25. I like to be really careful with these so I know I'm not doing anything silly. X squared plus 10x plus 25. I put the 25 right where I want it, right in that place where it's missing, missing the perfect square part. This plus 5. Now I've completed the square. I know by design that this thing that I just wrote down is x plus 5 squared. So I can rewrite it. X plus 5 squared plus 5. And this is equal to y over 2 plus 25. Now I subtract 25 from both sides. So I have y over 2 equals x plus 5 squared minus 20. And lastly, multiply the 2 by everything, and we get the following. Y is equal to 2x plus 5 squared minus 4. So you got to distribute the 2. And now I can sketch this. So recall what we started with. We started with this kind of parabola in standard form, which maybe is a little bit tricky. But now we know that it looks like this. So that tells me right away that it's going to be pointing up. And its vertex is at -5, -40. So over here, -5, -40. And it's going to be a little bit skinnier. Okay. I think it's actually not going to, it's probably going to cross the x-axis soon, I believe. Actually, I would say it's probably looking. Okay. Are there any questions on how you handle this when there's a constant in front of the x squared? Just move it over, forget about it, solve the problem as you would normally, and then resolve again for y. Please say yes if this example makes sense, and let me know also if there's any questions. Excellent, cool. We got a lot of yeses, great. Okay, so I'm gonna post tonight like a practice that I've done for these types of questions, practice tests that I've had, and please check it out. You'll see some ways to, I asked a few complete and square examples, make sure you know how to do them, and you can kind of reference these notes. Okay, so I won't do an example like this because it's essentially the same thing as we just did. Only thing is just you have to divide first and then reorganize. So what else is completing the square good for besides besides graphing? Well, it turns out it's also good for kind of like factoring. It's good for actually solving an equation exactly. So for example, if I want to find the roots of an equation, so use vertex form to find the roots. What's the big idea? Well, because it's vertex form, so first of all, what is the roots? The roots of a quadratic is when you set it equal to 0. So roots or zeros, roots, zeros, or solutions, or x-intercepts. These are all the same. They're all synonyms, not synonyms, x-intercepts. It just says when does the parabola cross the x-axis? So set the equation equal to 0 and solve. So that's when there's no y, you set y equal to 0. So y is equal to 0, which is equal to, let's say, ax squared plus bx. So this is so how do we use vertex form to solve for x? If you have, we did this earlier in the course. So remember, we looked at a few examples like this, and we said, I'll just give you an example. Can anyone remind me, how do we do this? X squared plus 5x plus 6. So what method did we use to solve this? We had this like in the first midterm. Hannah, what do you suggest? Like, what's a good method to solve this? If you remember, do you guys remember? We could factor this, right? We can write this as x plus 3 times x plus 2. And then we can find our two solutions, x equals -3 and x equals -2. And that's great. But sometimes certain equations, they just don't factor. If we remember, factoring is kind of like guess and check. You got to find two numbers that add up to 5 and that multiply to 6. And you can't always, for different pairs of coefficients, that doesn't always work. However, if you have written in, if you've completed the square, it turns out you can always find a solution. And this is related to the quadratic formula. Let's do an example where we can, just make a comment here. Sometimes factoring doesn't work. Doesn't work. We can instead take advantage of completing the square or of vertex form. So let's go back to one of the problems, similar one that we had earlier. So let's use vertex form to find the solution of this one. X squared plus 8x, x squared plus 8x minus 10. Okay. So if you look at this equation, first it's not even clear if it has solutions. I can't think of two numbers that multiply to -10 but add up to 8. Right? So how can we go about solving this? Well, let's try to write it in vertex form. So guys, what do I need to add to both sides if I want to make this into vertex form? Focusing on x squared plus 8x, what number should I add to both sides to make it go into vertex form? Guys, I got one good answer. Hand a little smaller. Careful here. Nice, nice, Archer. What number do I want to add to both sides? So which perfect square? Try to think about back to that first example. And this is just something, always think whenever you're doing completing the square, always go back to this pattern. It's really just based on this pattern. And I think all of you were really comfortable with it. So if I see x squared plus 8x, let's say, what number is missing? What's the missing number? So if I saw 6x, it would be 9. Hi, Lily. Lenny, do you want to change your answer? You're close. So x squared plus 8x, what's going to be the other one that's missing? Lily, what do you say? What number should I add to both sides? Nice. Yes, you got it. Okay, so I want to add 16 to both sides because that's what would make it. I just take that 8 divided by 2 and square it. So first I'm just going to write this. So I added this, I just kind of pulled it out of thin air, right? That's kind of what completing the squares, but we're allowed to do that if we add it to both sides. And I don't just do it for no reason, I do it because of a special reason. I recognize, I anticipate that this is going to be x plus 4 squared. So I'm not creating anything new. I'm just kind of rewriting something that I have. And this is equal to 16. Now I can take advantage of square roots. So I'm going to add the 10 over. So I get 26 is equal to x plus 4. And now, let me see here. Oops. And now I can take advantage of the square root. If I know that the 26 equals x plus 4 squared, that's the awesome thing of having a perfect square. It gives you access to the vertex form right away, but it also tells you that you can, if you just have a perfect square equal to a number, you can solve what is inside the parentheses by taking the square root. So you can actually use the square root to solve quadratics. So now if we take the square root of both sides, we get square root of 26 plus or minus is equal to x plus 4. Right? Because if some number squared is 26, then it's going to be it's either got a positive or negative square root. And lastly, we can now find what x is. X is equal to plus or minus square root of 26 minus 4 is equal to x. Or alternatively, usually it's written with the whole number part first, x equals minus 4 plus or minus square root of 26. Okay. Any questions on how you can do this? Yes, please say yes if this made sense. And I hope you guys see why completing the square is so nice, because compared to standard form, you can use the square root because there's no pesky, like the reason the square root doesn't work for standard form is that this thing messes it up, right? You can't move 8x minus 10 and then take the square root because there's x. But once you have everything in parentheses squared and then just a number, you can move the number over, that's no problem. And then you're allowed to use a square root. That's really the power of completing the square. Okay, so I want you guys to try one example. Please ask me if you have any questions. Did everyone get this down? I'm gonna write the next example, but I'll kind of leave this up as you're working on this. And this is pretty much it for completing the square. I mean, I'll mention at the end a bonus that I want you to try to. Oh yeah, that's it. You can't, square root of 26 is not a nice number, so your answer is going to be irrational. But at least you told me what the answer is, and it's really cool because you didn't need to factor it. You don't. Factoring will always do this guess and check thing, but once you know about completing the square, you technically don't need to factor. And well, you can write. You're allowed to if you want. This actually means there's something implicit here that there's two answers. So the first answer is x equals -4 plus root 26, and the second answer is -4 minus root 26. There's actually two answers. Okay. So let me give you guys an example here. Solve these two equations by using this approach. So x squared minus 6x plus 8. So don't factor. This one factors, but I want you to actually solve it by completing the square. And yeah, this is a good one. So try this one by completing the square or by doing vertex form. So I'm just going to make a comment here. Alternatively, you can write this as x equals -4 plus root 26, or x equals -4 minus root 26. This is a really good one to practice. It's also nice because hopefully you can do this by factoring right away. This is an easy one to factor. But I want you to do it by completing the square. This one, because you'll see this one, you actually, the thing in the square root simplifies, so you can actually simplify it as just a number. But most of the time we do this when we can't factor. Okay, yes. For the last one, you're not going to, you're just going to write it as two numbers because at the end, everything's going to simplify. And let me know if you're either stuck, totally not sure what to do at all, or if you finished. Unless I might have made this. Hang on, okay. I'm getting a few different answers here. Okay, that's good. Gabby, Olivia, you guys got different. We all got 3 different answers here. Well, actually, no. Olivia, yes, you got it correct. But you see, your answer will actually simplify nicely to be regular numbers. In this special case, because of the square root is nice. Nice, Lily. Well done. Archer, a little bit off. Does anyone, Archer or Gabby, do you guys want to walk me through what you did? Or you find your mistake? Yeah, just if you want me to if you want to try to spot your mistake, that could be helpful. Oh, Hannah, okay, cool. You guys, Hannah and Archer, you guys did the same, gave me the same incorrect answer. So I'm curious, would either of you be willing to kind of walk me through your steps? Oh, and Charlie also, yes. Yeah, so if Hannah, are you okay to do that?
Yeah.
Okay. So what'd you do first?
So first, I added 9 to both of the sides.
Perfect. So 9 equals x squared minus 6x. And then I'm going to put the 9 where I want it, right next to the 6x. I don't know why I should have made that, whatever. Okay. Now, what'd you do next?
And then I changed it to x minus 3 squared. And then
Excellent.
oh, I think I was supposed to subtract the 8, but I added.
Yes. Okay, good. I see. 3 other people did that as well. Good. You got it. Okay, so now let's do it together. So you subtract the 8 over. You're going to get 1 is equal to x minus 3 squared. And where do we go from here?
Then you take the square root of both sides.
Perfect. And this is an important thing. Whenever you take the square root of an equation, always do plus or minus on the number, right? Because there's always 2 solutions to a quadratic. And Hannah, for square root of 1, is there anything special about it?
It simplifies?
Yeah, it happens to be a perfect square. It's just 1. So we have our 2 answers. 3 plus root 1 is equal to x, or 3 minus root 1 is equal to x. And because they're, we have these terms, x equals 4 or x equals 2. Okay. And are any of you surprised that the numbers came out so nice? Does anyone else see how you could factor this equation? How is this equation factored? Why is this answer, why could we have done it a different way, the first way we done it? Remember? Yeah, how does it factor?
I was wondering, could you just add 1 technically to both sides?
Oh, Mason, which step? Where do you mean?
Because pretty much, I know you need to complete the square, but how I was thinking is you can add a 1 so to both sides to make it 1 equals the square, and instead of +8, it'll be +9.
Yes, Mason, that's a great observation. You can definitely do that. I don't like to show that approach too much because it means you have to add a different number. You have to think about first. You need to think about like I want to get to 9. Then I need to think about okay, what do I have already, and then add what I'm missing. So you can definitely do that approach. I do that sometimes, but be careful. Sometimes you just don't want to get mixed up. So like if you had -8 there, would you add 9? Or sorry, would you add 1, or would you want to add was it 17 to both sides? So you start having to kind of overthink it a little bit. But exactly, you're totally right. You don't you could have said, oh, I wish I had 9 here instead. I could just add 1 to both sides. That would save me a few steps for sure. But do you see a little bit of danger in doing that if you're trying to do it in your head? But that's definitely correct. Okay, and then yeah, just going back, Mason, how could you factor this?
Sorry, one more time.
How could you factor this one if you wanted to do it with the factoring approach?
Ooh, factor. How I would factor is I pretty much take the multiples of 8 and how I usually do it is I write it off to the side, then I kind of just try and do mental math to see how I can get 6,
Exactly.
or -6 in this case.
Yeah, so what two numbers that multiply to 8 add up to -6?
That would be -2 and -4.
Perfect. So this is just like an example to show you that this is actually works. This is 0 is equal to x minus 4, x minus 2. So in this case, it factors. You don't need to do all this fancy stuff with completing the square, but just show you that the number you get is the same. You get the same answer. Okay. Okay. Before I let you guys go, you could have also done this approach if there was a number in front of the x squared, right? You just divide it out. Like let's say there was a 5 over here. You just divide everything by 5, even the 0 by 5, that goes away, and then you solve as normal. So it's pretty easy to solve any quadratic using this way. So for next time, I want to give you guys a chance to think about this over the next 2 days. And I'm going to post some practice so you can start to do this. But here's a challenge. And you have now all of the tools to solve this challenge. So I really encourage you to do this. Let's say I have an equation like this. 0 equals ax squared. And we're just I'll step you through the first steps of this, the first 2 steps. How do you, so let's say, so given A, B, C as constants, A, B, C, solve for x. And what you see is that the quadratic formula that you guys know, that you probably have seen before, is really just a shortcut that summarizes the end result of doing all these steps. You don't have to, if you notice, what you're doing is very formulaic and very systematic every time. So similar to like Cramer's rule, where you just, okay, rather than doing all these reductions, you just have the final result and you can repeat it every time. Quadratic formula is similar to that. So I'd really like for you guys to learn how you can get there. So I'll help you with the first few steps. And you actually, what's really cool is that everybody, if you understood this last problem, you actually can derive the quadratic formula right now. There's nothing different. There's nothing special. Do you guys think there's anything special about these numbers that I picked? What was it? Here I picked 1, 8, and -10. And here I picked 1, -6, and 8. I mean, I just picked some random numbers and we just did the steps together. If I picked instead of numbers, I used letters, you can just do the same operations. But the thing is, you just can't combine the letters together. You just have to, your expressions might look a little bit messy, but that's not, that's kind of what we're going for. We want to get an overall final expression. So you can actually do this completely. So based on what I said before, can anyone tell me what would be the first step to solving a general expression like this? Like A is some number, B is some number, and C is some number. What do you want to do first? I'll walk you through the first two steps. What do you guys think? That's right, we want to find a number that makes it a square. But before we do that, and I kind of mentioned this briefly, what do you do if there's a number in front of the x squared? We want to divide it out. So that's the first thing we do. If we divide everything by a, this is still a 0. This becomes x squared. So multiply everything by 1 over a times 1 over a. This becomes b over ax. This becomes c over a. And I'm really, when I do these kind of operations, I really think of the letters as like separate numbers, and the variable x as like it's the variable x. So I try to keep them a little bit separate. I'm not, this way I don't get confused too much. These are just like numbers. Okay, I'll give you one more step, and then I'll try to ask you guys to just do the same exact approach. See if you can figure out how to do it. It's a little challenge. And don't look it up. You can try to solve this for at least. It's really worthwhile to try to do this on your own for maybe half an hour to an hour. If you solve it, it's really rewarding because you have probably seen a quadratic formula before, and this is how you can get to it. And you have all the tools you need to get to it, which I think is cool. What do you guys think? So what's the missing number? What do we always focus on? What part of the equation are we going to focus on? What's a really important number? 0 is important, but when I'm like this, what's part of the equation that I focus on first for this one? X squared and the next number, right? X squared minus 6x. And I always have to figure out, I take half of this and I square it, and that's kind of where I got this. So over here, what am I going to focus on? Anyone want to say what I should focus on? Not this thing. I want to actually focus on, nice, yeah, that's right. I want to focus on this guy. This thing I'm going to just kind of ignore, but this is the part that's important for completing the square. Now, oh, wait. What do we do to this number? This is just a number here. If I want to complete the square, what do I need to do to this number that's in the middle? What's the thing that I need to add? I need to divide it by 2 and then square it, right? That's how I got the 9. I take the 6, I divide it by 2, and then square it. And here's where it gets a little bit, you just have to be careful with your algebra and how you write things, and be careful with your parentheses and fractions. But it's the same exact process, it just looks more complicated because there's more letters involved. But all we're going to do here is we're going to write it like this: b over a times x plus b over 2a. That's because I cut it in 2, but I squared it. Oh, sorry. I have to add it to both sides, right? So b over 2a squared plus ca. That's it. That is the completing the square part. I cut the number in 2, and then I squared it. Okay, I will leave you guys to try to go from here. Really try to do this. I will be really happy if somebody, if a few of you are able to do it. Take your time with it. Get comfortable with kind of how the algebra works and how the expressions. One thing I would recommend here is, when you do algebra, you can try to get common denominators of the numbers so that you make them look like, whenever you have several fractional numbers, try to group them together so they just become one number together. And you would do that by getting a common number. And here, you have to be careful because you have parentheses. You have a fraction inside parentheses, and there's a 2a in there. So you have to be careful looking at this type of expression. This is going to be now a perfect square. And I'll leave it to you to try to continue this. And we'll go over it on Thursday. All right, guys, well done. Are there any questions about any of the examples? But that's it. That's completing the square. I encourage you to practice it more and review some of these examples, and then you'll become a master at it. Yes, I'll post these notes. You guys can see these examples. And I'll post also some previous tests where it was about this topic. All right, guys, I will see you on Thursday.
Thank you. Have a good day.
Have a good rest of your day.
Thanks, Dr. Bartleby.